Hello, in this lesson, you're going to learn about the law of sines. We learned in a previous lesson that for side, angle, side, and side, 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 the law of cosines was most appropriate. And then for law of sines, if you have two angles and the non-included side, angle, angle, side, or if you have two angles and the included side, and it's not necessarily a right triangle, then law of sines is going to be appropriate. We have two forms of the law of sines. Both of them are okay to use. I usually just kind of pick one and go with it, but basically you have the sine of the angle over the side, the measure of the side equals sine of a different angle over the measure of the side, and so on. So typically we usually just need two at a time to be able to solve for a missing piece, but this is just showing that they're all equal. So in the first example, we have two angles and the included side. Angle, side, angle. And we are trying to find one missing side A. So if side B equals 16, angle A equals 11.7 degrees, and angle B equals 23.8 degrees, then we can use this formula here to find side A. We have angle B, side B. We have angle A, and we're looking for side A. So now we just plug it into our formula, manipulate the equation a little bit, and then we can solve. So we've got sine of B over side B equals sine of A over side A, which we don't know. Now we can, since we have a fraction equals a fraction, we can cross multiply and divide to find A. So I should have given myself a little more room, but it is going to be okay. We've got A times sine 23.8 equals 16 times sine 11.7. For now, I'm just going to leave it in the exact form so I don't have rounding issues. And then this is kind of like, it's a constant times x, or a coefficient times x, kind of. I mean, that's not what it says, but so all we have to do now is just divide by that coefficient. Sine 23.8 on both sides, sine 23.8. And we have A equals 16 sine 11.7 divided by sine 23.8. And now I'm going to type that into the calculator so that I get a more accurate answer. Just make sure you're in degree mode before you start typing your, your problem in. Pause it, type it in, come back and check. So I'm going to do parentheses 16 sine 11.7, close the parentheses, that's my numerator, divided by parentheses sine 23.8, close it. So I'm just telling my calculator that all of this is in my numerator and all of this is in my denominator. That way we don't have any issues with input error. And we get about 8.04. I don't have the units here, so we'll just call that good. So that's all you have to do. Just a little cross multiplication, cross multiplication and division. Easy peasy. The next one's going to be a little bit more involved because we're going to be finding, basically we're going to be solving the triangles. We're going to find side N, angle M, and side M. Have to say those clearly. Actually, I'm going to move this out of the way because I'm going to need space. I'm going to put that over here. So that's out of the way, and I'm going to highlight it so we know it's the answer up there. All right. Let's see. Let's orient ourselves to the triangle. All right, we have angle, angle, and the non-included side. So I do know I'm going to be using law of sines here. I'm going to start with what I think is going to be the easiest thing to find. And that's going to be angle M, because I already have two angles. So to find angle M, all I have to do is say 180 minus the sum of the given angles. I don't have to use sines, cosines, Pythagorean theorem, nothing. Just simple addition, subtraction. And then I'm just going to do that and have one missing piece. And we get 65 degrees. So, yay, we did it. Okay, and now I can use law of sines to find side N and side M. I don't have that labeled. Let's see. Let's start with side M, since we started with angle M. It doesn't really matter. I'm just picking one and going with it. So that means I'm going to do sine of the angle, 65, over the measure of the side, which is what I'm looking for, equals sine of, let's see, if I use 73, then I'm going to have to use side N underneath, which I don't know yet. So that would put me at two unknowns, and two unknowns is not going to help me in this problem. That means I'm going to have to use the other angle, angle 42 and side G. I do have those two pieces. So that's going to be kind of my anchor. That's what I'm going to use to help me solve this. Sine of 42 over 12. That's side G. And then do a little cross multiplication and division to solve. When you cross multiply and divide, you're going to end up with 12 sine 65 divided by sine 42. That would be the exact solution, but I'm going to get an approximation here. 12 sine 65 over sine 42. Uh-oh. Did I type something in wrong? I did. I missed a parentheses. I don't think I really even need a parentheses there, but just for the sake of consistency, I'm going to put that there. There we go. And we get about 16.25. So we have two of the missing pieces. Now I just need to find the last piece. At this point, you can use law of cosines if you wanted to, but I think it's going to be a little bit cleaner if I just stick with the law of sines, and then that way we get some extra practice with law of sines. In the next example, we're going to use law of cosines, but so just get prepared for that. But for this one, I'm going to use law of sines one more time for side N. So we get sine 73 over N equals, I could use M because I already have it. I've solved for both. But here's a trick. Here's a trick in math. M was not given to me, and I solved for it. And while I'm pretty sure it's right, I'm really sure it's right, but let's say I'm a student, I'm pretty sure it's right. You might account for the fact that maybe you're not right. And so if you use this value that you found and it's wrong, then what you get here will also be wrong. So it's a pretty good idea to go ahead and stick with what I called an anchor point, an anchor information, whatever earlier. Something that you know is true. We know that angle G is 42 and side G is 12 because it was given to us. So that's going to eliminate extra errors in the problem. So I'm going to use that, sine 42 over 12. And then that way I know if I did mess up M, I'm safe on N. I'm not going to get the whole problem wrong. And then we're going to do some cross multiplication and division to get 12 sine 73 over sine 42. And then we'll go ahead and type that in to get our approximate answer. We get, actually, you know what I'm gonna do? I'm gonna do second enter. I'm gonna change this to 73. 12 times 73 over sine 42. There you go. That was faster. And we get about 17.15. So N is that. And we did it. We got all three missing pieces. All right, our last triangle here, we've got a lot of missing pieces. So I'm going to try to break this down. I'm not trying, I'm going to break this down into smaller problems. Basically, essentially what end goal we're trying to do is find X. It's a little bit blurry, but that's X right there. But I don't have enough information. If you were to try this using law of sines, I don't have enough information to find it. It doesn't fit the angle side or angle side angle or side 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 or what was it, side angle side. So I can't use any of the laws that I already have. But if I break this down into, let's first focus on this triangle. For that triangle, I have side, 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 which means that I can use law of cosines to find what I'm looking for is this angle, I'm going to call it theta since I don't have any letters here. And basically what I'm leading to is if I can find this angle, then I can use law of sines to get that side. Because also what I have is another angle and another side. So I will be ending up with law of sines because I have angle, side with the formula. But I'm going to have to use law of cosines to figure out another angle to use. So that's kind of the background to where I'm going with this. And sometimes when you have something like that, you just kind of have to play around with it a little bit to figure out, okay, what do I need to find so that I can end up here? So this one's probably one of the harder problems for this type of lesson, but I wanted to give you something that is a little bit harder so that if you come across it, you know what to do. All right, so I'm going to use law of cosines on the purple triangle. Just to practice that, I want you to pause it, try it on your own, and come back. I do want to say that kind of looks like a 12.8 right here. It is actually a 12.6. If you did 12.8, your answer is going to be a little bit different. That's fine. You can leave it as 12.8 if you want to. As long as you've done the formula correctly, the law correctly, you're going to be, it's okay. No worries. You can just change it out. But it is a 12.6, so this is where I'm starting. You want to make sure that you start with 8.9 here because we're looking for its opposite angle there. And then go ahead and finish it out. Once you simplify a little bit, I went ahead and did the 8.9 squared, 11.2 squared plus 12.6 squared. If you did 12.8, you're going to get a little bit of a different answer there, but as long as you did the process correctly for 12.8, you're going to be all right. And then I subtracted 284.2 over, and then divided by the coefficient, 282.24. I dropped the negatives because it was a double negative there. And then take the inverse cosine. I'm kind of blowing through this process because I've already taught a lesson on it. So hopefully you're following. But an inverse cosine, second cosine of, make sure you're in degree mode, 204.99 over 282.24. And we get about 43.4 degrees. So now we have the angle we need to use law of sines. So I can use the law of sines on the larger triangle. Ignore the diagonal down there, the 8.9. And we have sine of 43.4 over x. And then I'm going to use, again, like I said earlier, an anchor point. That's not the technical term for it. It's just what I'm calling it because it's something that I can be 100% confident about. Angle 31, sine 31 over the side opposite. And then go ahead and cross multiply and divide. You should get 11.2 times sine 43.4, all divided by sine 31. And then when we type that in, we will get 11.2 sine 43.4 divided by sine 31, about 14.94. And x is what we were solving for. So we're done. That's it. So hopefully that gave you a nice little review of law of cosines and then a nice little lesson on law of sines. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I will see you in the next one.